Okay, everyone. So today we are going to be going through how you name compounds and how you write formulas of those compounds. We're going to really focus on ionic compounds because that's the unit that we're studying right now. But we are going to touch briefly on how you name covalent compounds. That you just need to be aware of for now. We'll practice it a lot more later. Okay, so we're going to start out with just talking about naming compounds in general. For the most part, your compound and the name of it is showing you what is inside of that molecule. So we could write out the entire formula each time, but a lot of times we'll just name it instead so it can be easier said verbally. Like it's a lot easier to say, oh, that's sodium chloride versus saying that's NaCl. It's just something that we do in chemistry. So it represents what's inside of that molecule. And we're going to look first at naming ionic compounds. So ionic compounds, you're always going to have positive and negative ions because we have the metal, which is the cation, and then the nonmetal, which is the anion. And we're always going to put that positive ion first. That's always going to come first in the formula. And then the second part is going to be that negative ion. So if we look here, anions end in "ide," if we know that the second part of the formula has to be the anion or that negative ion, we're going to have to change the ending to end in IDE. So if we look at these examples down here, we look NaCl, that's composed of sodium and chlorine. If you just write sodium chlorine, that's telling me that you have a sodium atom separate from a chlorine atom. So what you need to do to show that it's in a compound with something else, you change chlorine to chloride. You change fluorine to fluoride. You change oxygen to oxide. So whenever you have an ionic compound, the second name should always end in IDE. And the only time that changes is if we have something called polyatomic ions, which we'll see next. Polyatomic ions are sort of these weirdos, and essentially they're cations or anions, so they can be positive or negative, and they're groups of atoms that really like to stick together. So you always find them in groups. So here we have like nitrate, here we have phosphite, here we have sulfite. They always kind of stick together in a group. And they have charges to them. So if you'll notice, like all these guys have a charge right here. So these charges represent whether it's positive, negative, whatever. And that charge tells you how positive or how negative. So the same way that we have charges for the regular old atoms, the polyatomic ions will also have charges with them. So if we're looking at, let's say, an example, oh, not that one. If we're looking at, let's say, sodium nitrate, sodium has a +1 charge, and we look over here, nitrate, we write like this. So that written in a formula would be NaNO3, just like that, okay? So you'll always find the polyatomic ions, they stick together in their own little group. They don't like to be separated from one another. So you wouldn't call this sodium nitrogen oxide, you would call it sodium nitrate. So whenever you see them in this group like this, that's a hint to you that it's going to be a polyatomic ion. When you have transition metals, so this only applies for transition metals, okay? So things found in the D block, let me write here transition metals, they can kind of pick and choose what their charge should be. So if you remember how we have those pluses, like +1, +2, +3 written above the periodic table, we skipped over the D block. The reason why we did that is because these transition metals or the elements in the D block can kind of pick and choose how many electrons they want to give away. So iron, tin, lead, and copper are really common to have more than one charge. They can pick and choose, but pretty much anything in the D block will do so. But the examples we look at here are lead-2 and lead-4 sulfate. So if we look at this formula, you'll eventually be able to get to the point where you can look at a formula and figure out whether or not it's lead-2 or lead-4. So the difference between these two, here, lead has a +2 charge. Here, it has a +4 charge. Okay, so when we learn how to write formulas, you'll be able to make sense of how we can figure out that this is a +2 and a +4. But for right now, you just need to be aware that they can be multiple charges. So if you see something coming from the D block, you know, oh, I got to check and see which charge it is, whether it's +2 or +3 or +4 or whatever, okay? So we're going to go through, we're going to name a couple examples of these. What I'd like you to do is try to see if you can do the other ones and then have me check your work once you've watched this PowerPoint. So I'm just going to do, I'm going to do this one, I'm going to do this one, and I'm going to do this one. Okay, so if we look at the first one, we have zinc, and we have fluorine. So this is a really easy one. We just call this zinc fluoride. So remember, I take that fluorine, I cut off the ending, and now I make it ide. The next one, we have calcium here, and we also have this guy that's kind of grouped together, and if we remember, that's what we call polyatomic ion. So you're looking for the polyatomic ion, that's NO3, and that's going to be calcium nitrate. Now, you might be like, oh my gosh, where is she getting these names of polyatomic ions from? If you look on the pink sheet that I gave you, there is a list of polyatomic ions there with their formulas as well as their names. So you never need to memorize them. You just need to have that pink sheet out ready to go when we're naming compounds, okay? And finally, I'm going to do this last one. This one's a little bit strange because now we see that we have this polyatomic ion in the beginning and then chlorine at the end. Well, if you look on that pink sheet, you'll see that NH4 is a polyatomic ion, and we call that ammonia. So this is ammonium. Is this ammonia or ammonium? This is ammonium. I'm sorry, ammonium chloride. Had to look at my own pink sheet. So we call this ammonium chloride. This beginning part is the polyatomic ion. For the most part, the polyatomic ions will be negative, but in this case, we can't have the positive one if we have ammonium, okay? So go ahead and try those others, see what you can do, and then check back with me. When we name covalent compounds, we're just going to touch on this briefly. We don't name them quite similarly. Instead, what we're going to use are Greek prefixes to tell me how many atoms are in that compound. So in this case, we have sulfur and 6 fluorines. We call this sulfur hexafluoride. Now, when we have this first part of the name, I only have to put a prefix with it if there's more than 2 of it. So if you look here with sulfur and here with these 2 carbons, even though there's 1 sulfur, 1 carbon, we don't put monocarbon or monosulfur. We just keep it the plain old name. So it's assumed that there's only 1 of it. However, if there's more than 1, if we look here at this 4 phosphoruses, we have to put that 4 in the form of tetra. So this is tetraphosphorus. And then decoxide tells us that there's 10 oxygens. The Greek prefixes you don't have to have memorized. They're on your pink sheet as well. So as long as you have that, you should be good. We're going to focus on more of this later. Right now, we're worrying about ionic. When we want to write formulas, we're always going to have the cation come first and the negative ion or the anion come second. And the big thing is that the charges have to balance. So the plus charges have to balance out the minus charges. So what we're going to do is I'm going to show you a trick. So I'm going to show you the trick with, let's do this one and this one and this one. Okay, so 2, 4, and 7. The trick is you take whatever, I'm going to zoom in here, you take whatever this superscript is and you move that number to the other atom. And here we have -1. We do the same thing here. So the formula for zinc and bromine is ZnBr2. Okay, so you see how I took that superscript and I stuck it over? That's what I'm going to do for the other ones. So here we have calcium down here and hydroxide over here. Hydroxide stays as its own compound, so we're going to write Ca and then in parentheses OH2, telling me that there are 2 of these hydroxides. Okay, and then finally we're going to move down to this last one. We have calcium, which is that 2 is going to go down here. The phosphorus is 3 is going to go there. So the way we write this is Ca3, and then in parentheses, PO4-2. Now notice I'm not changing anything about these polyatomic ions. I'm keeping them as their own unit, and I'm putting that subscript outside of the parentheses, okay? Try those other ones, see if you can do it. If you can't, let me know and we'll work on it. And then finally, this last thing, some of the elements on the periodic table will always come as a package deal, meaning they always come in 2s. These 7 elements here always come in 2s, so you need to be aware that they're always going to come as this package deal or the the diatomic molecules. The way to remember that, have no fear of ice cold beverages. There was something that rhymed with fear that started with a B, but it was inappropriate for school, so I changed it to beverages. So you just need to be aware that these elements try to come as a package deal unless they're in an ionic compound. So when they're just by themselves, they come as a double. Let me know if you have any questions with this. We'll be going over this a lot in class, okay? Awesome. Great. Goodbye.